Alright. Let's continue. Where is it? The finding a function. Okay. Okay, so we have some kind of problems. A problem with this expression. Basically, when we try to assign a symbol that contains another symbol, we will get something gibberish, I guess. Let me show you. Okay, if we define x like this, right? Then we call x invoking. This is working fine. Maybe something like this. X and Y, right? But if we are putting, what is it, another variable or another symbol instead of this symbol, we get gibberish. So we need to figure that out. But before that, I think let me commit that first. Okay. Pass empty array. Okay. Alright. Okay. If I understand correctly, okay. Seems calm. Cannot define non-symbol. How to trigger that? Like this. Okay. Scripts. Hello. Indika bro. Oh yeah, I know put helmet hero, but currently I'm using another resource, and I want to finish this first before checking out another resource. Okay. Right, let me commit this first. I'm still not sure when will be triggering this. Is it when we do something like this? Oh, okay. Yep. We are triggering this error. Okay. Functionality to define during runtime. Previously we ran this if put in symbol or functions like head, tail list, and so on. And now we can save symbol to the environment during runtime like this. X. There's still a problem when we try to save a symbol with another symbols. Symbol as value like this. Please, somebody said. Possibly a problem when we copy the symbol to the environment, but we did not assign new and just use my location ST. Abstract syntax tree. So when we delete the memory location, ST with MPC, like this one, MPC ST delete. The memory location we save in the environment, and the environment is environment become linking pointer. Let's see how it goes. Possibly this is a problem when we copy the symbol to the environment, but we did not assign new memory location and just use memory location from IST. Right, what I mean by that is, where is it? Something like this. You're just directly copying the symbol memory location. The problem is that when we delete the AST, but this is just a hypothesis. I'm still not sure if this is true or not. Now that make me wonder if we do this. What happened? X, Y, Z. Right, because we didn't delete the abstract syntax tree memory location, so it appears. But then we will have memory leak because we didn't free the use memory, I guess, something like that. So with that in mind, maybe we should do some allocation here. Allocate here. Alright. Should I use copy count? Let me check. Where is it? Okay, no. Yep. just just copy like usual, I guess. Yeah, we still use string line. Then we can kind of use this rather than using, what is it called? Using alloc util. Alloc size in here to find that, and then using malloc with alloc sense. After we can be sure there is no integer overflow happen. Okay, where is this one? Malloc size. And then if this one error same, string copy, what is it again? Value. Okay. I kind of forgot. Destination first. Oh, my stomach. Destination first and then source. And then source. Okay, destination first and then source. And then wait a minute, do we delete the environment? Oh, right, I cannot forget about this. Okay. Right before the cleanup. Oh. There. So we initialize the environment with built-in function, and then we delete that. Let me commit that. Environment after terminate wrapper. or maybe make sure we are cleaning up the program like that. Okay, copy this one. And we put okay, let's compile it. Let's find out. Okay. Second. So what happened there? Interesting. Let's take operate at LNV. No. In def, I guess. Okay. Still 9, continue. Right. At least I said next. To okay. Seems okay. Next. And we put this one. Why is it? Interesting. Let this do. Okay. And again. And we put okay. let's disable that first. Okay. Reset. Right now, enable that. This one enable. Okay. Next. Step. Okay, we are in env put. Let's check this. Okay. Next. Next. Okay. Okay. And we count 13. Okay. Next again. What about the eye? One. Okay. Six. Maybe something like this. Nine. Can we like there is N. Interesting. Okay. Next. Okay. Alright, next. And come. If. Okay. No, okay. This one. We are copying the function. Okay. Next, I guess. Cutter. Okay. Next. Unlock size. Okay, next. Wait, and fit down 14, okay. So and we seems 13. And we seems 13 like this. Oh wow, what? Unlock size. Egg. One, two, three, 4, 5, 6, 7, 8. Okay. No, it is not. No. Okay, is it the cause of the segfault? Next. Okay, next. But in time. 434. This one. Okay. And then next. Where is it? Okay, this one. Next. Next. Oh. We haven't encountered segfault until now. Okay, interesting. Is it this one? Return result. Print. Print learn. Okay. Alpha there. Okay. When we wait a minute, we successfully print the symbolic expression here. This one. Yeah, trying to clean up that. Okay, I still delete. Okay, free input. Okay. Okay, no. Hold on a minute. Wait, what? How is it different? Segfault, even though it is success in here. Interesting. Yeah, why this is success? There's a maybe it is in the print. Whatever. Okay, let's check that out. Okay. Hello, welcome, Jimikan. Oh, well, let me answer that now. For Paklara. Currently, I'm trying out something different from the book. So, yeah, I'm mostly following this book. I'm currently on the, what is it called? Currently on the chapter 11, and well, because my, what is it called? Because my implementation is different than the book, so I encounter some problem, and now I'm trying to debug the problem myself. That's basically it. And maybe I clarify the left. Okay. I'm currently in the debugging session. So usually when I'm in debugging session, I don't look at the chat. Okay, I'm to focus on finding out the problem, Okay, Senegal, how is it going? Well, I'm currently debugging some of the problem, which is quite interesting. So the problem is that, let me demote it. When we are trying to define a variable, right, like this, and we are trying to print that variable, we successfully printing that value, right, 69. But then when we try to, what is it called? To save the value of, what is it, another symbol, let's say, like this, I got segmentation fault. So yeah, there is something wrong there. But the interesting part is when I do this, it succeeds. But then when I do this, yeah, segfault. Now I do this. And let's see, can I do this? X and Y, okay. And then, now let's do something like this. A, B, C. Oh, interesting. Segfault, okay. I'm trying to find out the pattern here. 69, okay. Is it X, Y, Z? Segfault. Is the segfault because we are using X? Let me try again. What is the pattern here? PC. Okay, let me text note. Segfault when X 69 and then APC, another segfault when directly. Okay, I am in debug mode with all the debug information. Okay. PC directly. Interesting. Oh. So it succeeds. But when we do this, we got check fault, okay. And then bring out, okay. Interesting. Okay, let's try this first. We are defining the argument directly. Okay. Value type. Okay, and then next we will go into this one. Next. Okay. Okay, now let's step into this function and for symbolic expression. Right, okay. Next. Okay. And for again. Let me check. Alright. So we are entering this condition. Next. And we get. Okay, let me step in. Let's check. Okay. If it is exists, we return the copy of it. Okay. If not, return an error. Okay. Okay. Oh. We found. Wait, let me try. CMP. Or maybe just using this def. Okay. Oh. And then the value. Okay. So we are returning the, what is it called? The built-in symbol. Okay. Interesting. Let me think. Here, back to info again. I should call it symbol. Now, hold on a minute. Let me check again. If it did not exist, we return an error. The net value, where am I again? Eva. Rather than calling this var, maybe I should call this sim, because we are getting the symbol, I guess. Okay, but yeah, let's do that later on. Or not. Okay, print var, and then next we are going back to a var symbolic expression here, right? Oh, let me check. Alright, so if we got an error, maybe we'll return that immediately. Okay, next. Oh. Alright. How many count do we have? 3. Okay. And we are currently in this one. Okay. Next. Step in. Okay. Print value. Okay, code expression. Right. Code expression. So let's next. We returning the value as is, because well, where is it? This one. Okay. Next. Is it an error? Wait a minute. Value cell I. One, okay, on index 1. Type code expression, okay. Let's continue. another one. Step in again. Code expression. Okay. This is the code expression, right? This is the one, I think, that we are currently checking out. 3, right? I think it is in cell. Sim. Okay, this one. A. And then if we change this to 1, it becomes P. A, B, C. Right? C. Okay. And then next, return the value as is. Okay. Going back to here. Next again, right? We are exiting the for loop. In here, value count 3. Okay. But I'm kind of curious though. What happened if we do this? X, Y, Z. Okay, so we still got the seg fault there. Alright. Okay. Directly in print out arcs. Print out. So is it in the print out stuff? Okay. Next. What is the value here? Symbolic expression, okay. Built-in def. Okay. And next. Step into identificate this. Okay. Copy. Let me check. Def. And the value arc. Okay. Next. Okay. Login again. 14. This make me curious though. I equal 0. Okay, next. Let's just change the index to 13, I guess. Next, okay. FIFA. Wait a minute. Okay, code expression. Next, check fault. Interesting. So we got a check fault in file copy. Is that it? When the type is code expression, let me test the new changes first. Okay. Then, it print, but we are printing gibberish. And well, if we didn't delete this abstract syntax 3, it should be working fine. Right. Now let me check. 69 AP. Okay, it works fine. If we didn't print up the abstract syntax 3, because my hypothesis is that we are saving the memory address from the abstract syntax 3 output, and then when we delete this, the memory address become, what is it called? Become dangling pointer, something like that. Interesting. Okay, let me copy. Or maybe the way I put the symbol memory address. Yeah, like where is it? Like in this one maybe. Let me check. See, we are directly using the memory address from the parser, from the abstract syntax tree parser. If we using malloc here instead of on the copy, well, let's try that out. I mean, the problem is that we are already deleting this or freeing the abstract syntax tree, right? So flow indicator. Read. And this one read, and then is the eval again. Yeah. I mean, if the evaluation have an error, we just printed out the, okay. And sign in. Flow indicator, okay. You know what, maybe doing it like this make more sense. Unlock size. Okay, and then string symbol one unlock size. If there is an overflow, we throw an error. Okay. And then allocate that size value equal null. It is there is a problem in allocation. me throw an error again. And then we copy the destination, and then what is it called? The value, the source for the strcpy. String copy. Okay. Let me try. AP, okay. And then AP 6942 wait, where is it again? Oh, arc list, okay. Arc 6942 A B. Let me try to swap this. A42, okay. Then B69. A and B. Okay. Alright. Okay. I think this comment is irrelevant anymore. And then if not be deleted. This make me wonder. Whoosh. Oh, this is just put the string literal. Okay. Let me copy this in the chat in case anyone wants to take a look. Not deleted. The value X69 X, okay. Arc piece XY still okay, but if we do this can you like do this? An equal symbol, okay. $69 42, 16, 42, 0, 52, unequal, okay. And then what is the x value? Okay, this one is x, there's also y, and then we'll plus b. Now we can do this, I guess. Right, okay. The value of sim came from Vietnam. Okay. Allocation, sorry. The allocation of the symbol came from alpha sim. Maybe something like that. So be fine because we already knew that. Okay. Symbolic expression. You make only constant is memory leak. This one. And for num, just directly passing the number in this one. Okay, maybe I think some comment here. New. We can save that. Save the symbol address to the environment. Like XY set. Bro, are you Chinese? No. I'm not Chinese. I am Indonesian. Actual Indonesian. Okay. Yeah, I'm not sure if this is the right solution. I mean, like, what is it called? Yeah, having dynamic memory allocation can make handling stuff quite complex, I guess. Now I'm curious though. Previously, the symbol is like head or something like that. Something like this, right? And now, I forgot what I'm gonna do next. Okay. Starting import. Not ASD. They have not. Those have not been deleted. Memory trace have allocation tempo. Alpha scene. Okay. Current allocation of symbol. Of the symbol came from alpha scene. I mean, in the book, right? Where is it? Not this one. I think this one. Right, we create a new memory allocation. Even though in the, what is it called? When we read from the abstract from the abstract syntax tree, we already create a memory address or memory allocation. Where is it? Alpha read. I think this one. Okay, this one, right? Alpha sim. Alpha sim. See, we already create a new memory allocation in this one. And the previous problem is when, where is it? When we are deleting the abstract syntax tree memory allocation, or freeing, I guess that's the word. This is here, this one. So yeah, it becomes a dangling pointer. And then what this one, but this one. Okay, commit, okay. Fix. Fix. Saving. Symbol as value into environment. Dangling pointer. Dangling pointer when save symbol as value in environment. The problem is that we are using the memory address from SD abstract syntax tree that the MPC parser created for us. So when us in the evaluation, so when we delete those memory allocation, I guess. Evaluation. So when we delete this memory allocation, and PCISD delete, the memory address become dangling. not really delete, freeing the memory address become invalid. To fix that, the easiest solution can think of is to create a new memory allocation when we read. To create new memory allocation when we read from st with evaluate. I think that's evaluate, right? PCST. Okay. Read from ST with evaluate. Memory allocation when we have symbol when we read have symbol how to explain this? Create memory allocation when we have symbol from AST file sim. So that when we freeing the AST allocation with we still have the new memory allocation. The memory allocation for the symbol. Allocation for the symbol. Okay. I've not been freeing. Maybe that's the word. Freed, is that the word? Yeah, maybe that is the word. Currently the memory allocation, the symbol came from Fasim. Okay. For the symbol that we can use in the environment. Oh, no. Fasim or string literal. I mean, there is, what is it called? And we put, right? And this one, the name is actually came from string literal. Right? This one. So it's not necessarily from the, what is it called? Not necessarily from the eval sim, but also string literal. String literal, something like this. Right. Okay. We can still have the memory for the symbol that we can save in the environment. Okay, let me read this again. The problem is that we are using the memory allocation from AST, abstract syntax tree, that the MPC parser created for us in the evaluation. So when we freeing this memory allocation with MPC IST delete, the memory address become invalid. To fix this, the easiest solution that I can think of is to create new memory allocation when we have symbol from IST with eval sim. That when freeing the IST memory allocation with MPC IST delete, we still have the memory allocation. You know what? That make me wonder. Do it right. We are freeing this one. Okay. We are freeing this one. So maybe this is not the right solution. And my concern is that if we are using the symbol, right, but we didn't save that into the environment, the symbol will keep creating memory allocation. Yeah, I'm still not sure why this one did not work. Okay. And forget. Oh, maybe. You know what? Maybe we need to create a new memory allocation in here. In lenv put, other than the copy one. Maybe. But then and I mean, where is it? Let me put same cell. Okay. What? Let's abort it. Reset. Alright, I don't think this is the right solution. So let's test this. How many kids test do I have? 8. Okay, interesting. I think this is my first attempt. Okay. Maybe Invitel. Oh, I don't have this information. Okay. I forgot about those explanation. Let me put that in the header. Like def. Okay. Alright. Okay. Is there any new information? No? Okay. Delete that. Malloc handler. Read case. I think I already done that. I think I didn't that previously. Okay. Let's remove that. Okay, delete. What is this again? Oh, this is my attempt to make the pointer null. Okay. Invalid same. I don't really remember what this one. I don't think we need this anymore. Yeah, so this one, okay. Okay, so I guess that's it for now. We will try again on the next session, I guess. I'm still not sure why adding the memory allocation in a file copy did not work. Well, we will figure that out on the next session, so thank you for watching and see you next time. Bye bye.